Thank you, Joe, and thank you, Ian and Dot, for the invite for the presentation. So, Plutonic, some of you have probably seen us on LinkedIn. Apologies if I've bombarded your feed with all sorts of garbage, but I'd like to have a bit of fun. Chasing hypergiants, I guess. What's a hypergiant? We talk about giants and supergiants. Giants being somewhere up in the sort of 10 to 15 million ounce gold equivalent range, and supergiants being an order of magnitude larger than that. I don't think it's right to call a hypergiant an order of magnitude above a supergiant. You're talking about something that's probably not possible, but yeah, we're talking about things that are 200 million ounce plus, so things like Muruntau and things that may become bigger than Muruntau, I guess, over a camp scale um, project. So that's what we set out to do with Plutonic, look for big systems. And we started initially in Queensland, just on the other side of the border from where we are. So this is our project. It's south of the Plenty Highway, so way out on the eastern border of the NT with Queensland, a couple hundred kilometres west of Boulia, in the Simpson Desert. So it feels remote when you're out there, but there's good tracks. It's good access. It is a long drive though. Boulia is about 5 hours. Mount Isa 6. Townsville, where our field manager lives, is about 2 days, where we drag all our stuff out from. And for me, driving up and back, it's a 4 day drive. So it's a long way out there, wherever you come from. But the sunsets are beautiful, and the flights are pretty horrific, actually. So 6,500 square kilometres in the Simpson Desert. We've got there's a bit of outcrop, but there's a lot of cover as well, both sand dunes and transported aeolian sounds. And so we ended up in this area using some sort of state-of-the-art uh, geophysical, algorithm-derived sort of structure detection that sort of put us in the area of that NT Queensland border. Originally looking for IOCGs on the Queensland side, but we were struggling to do a deal or negotiate with the traditional owners on that side of the border. And while we were negotiating, we saw these things in the satellite imagery that very white. And we thought, what could these things be? And there were some sort of weird things we found mapped in the hay sheet, 250K sheet. They're meant to be quartz veins, but we hadn't really known about these things. So one day we went and had a look, and the first vein we sort of drove out to is now called I'm Not a Vampire. And it continues for about 50, 60 kilometres, and it outcrop for up to 2 or 3 kilometres at a time, up to 40, 50 metres wide and 40, 50 metres high, and just full of beautiful, epithermal textures, blade textures, um, crustiform, coliform bands, and all sorts of stuff. Bit of gold and silver, and even a little bit of copper in these veins. So looked interesting. Next thing we knew, we picked up, thousands of square kilometres of ground. Back in about 2001, I think the ground was granted initially. So we had our first field trip out in May 2021, and since then, I guess we've done a fair bit of work. 1,200 odd rock chip samples. Um, again, people suggest we do broader scale geochemistry, but it's really difficult to do on sand dunes and transported sort of cover. So we've decided that rock chips probably being the most useful sort of medium for any form of geochemistry. Then realizing we probably had 200 or 300 million years of inland seas stripping all the metals out of the top 50 or so meters of the ground. So yeah, we've got some good assays up to 0.3% coppers and 0.7, 1.3 golds and stuff like that. So these systems are fertile, but until we drill, which will hopefully be later this year, we won't know exactly what we're looking at. We did a very large, or 1,800 square kilometre airborne hyperspectral survey. Vista did that for us. I'm not sure if Lee's still around, but he processed that data for us. Strongly recommend Vista. And it sort of changed everything for us because we could start seeing where the small outcrops were over such a large area. So we could drive straight out in our new Can-Ams and start sampling. And as we did that, we sort of realised almost every rock we picked up was either mineralised or ex-mineralised or altered or something other than just plain old rock. Um, and then more recently, we did some geomechanical modelling, trying to get a feel for what is the overarching tectonic sort of you know constraints on potential mineralisation. And it turns out the stress and strain fields are more consistent with those of the Tasmanides than the Alice Springs orogeny for our area. So we are inferring potentially that we are somehow influenced by the Tasman orogenesis much more so than the Alice Springs orogeny. And we certainly don't see the same degree or any metamorphism that we see at Harts Range just next door, really. So a very different little bit of crust there. We've done a bit of geochron on the rocks. Um, yeah, we did some age dating on some older granites, just because they were altered. We just want to get a feel. And then we did rubidium, strontium, and argon, argon. That sort of placed their ages somewhere between about 512 and 469 million years for the rubidium, strontium. So we're talking about events that are consistent with the Delamerian and Staveley arcs, I guess, in the eastern part of the country. Um, but argon, maximum closing age is about 450 to 400. So again, these do overlap with the Alice Springs orogeny. It's just that these, as alteration things, combine with what we see with the structures and the inferred tectonic, um, makes us feel that we're probably more influenced by what's happening in Eastern Australia. And then last year we did a huge IP survey covering lots of uh, prospects and generating new ones, and we'll talk about those results shortly. So I thought I'd just show a map of the sort of stuff that we've done. So the red isosurfaces are 3D mag inversions. So these are either buried or, you know, new, younger, intrusive belts that might be related to mineralization, or they could be reflecting the older 1760 to 1730 granitic belts. Now, we don't have enough evidence either way to know yet, but they are consistent with the structures that are hosting mineralization. So red blobs are that. The background is 112-degree oriented tensile failure. So again, something that appears from compression coming from the southeast or east-southeast as opposed to the north-south Alice Springs orogeny. And then just the IP pseudo-sections. This one's important. The background image here is mag valleys. So this is another algorithm-derived product from geophysics. It's just mapping out the areas of low magnetism. And it works pretty well in terms of defining the structures that most of the mineralization that we've seen. So it's effectively mapping out hydrothermal alteration over large areas. Now, when I say large areas, these things are huge, and you often get multiple overprinting systems just interconnected all the way across the landscape. That anywhere you go out there, it's either altered, uh, silicic, or Scott Halley suggests potentially large-scale adularia alteration, so very large-scale potassic alteration beyond anything he's seen before. But again, we don't really know what it means yet. But I think we've had enough data to go ahead and do the IP to start finding drill targets. And I guess this is a little bit of a summary. Too many words there. That's basically the geochronology and the geomechanics, which leads to this interpretation that we have called the Kris wishful thinking subduction zone out on the edge of the Tasmanides there. Um, Again, this is just more of an expression of how we see what's happening. We may be completely wrong. Doesn't bother us. We're here to find all, not win geological arguments. But from everything that we've done, this is sort of what it looks like. And there's other evidence further up in Queensland to suggest this, but it's commercially sensitive, so I can't really talk about it. Okay, so here's a really messy map because there's too many words and too much stuff. Just showing scatterings of, tellurium, selenium, bismuth in particular, arsenic in certain places, but copper, silver, a bit of gold. So, um, but this really sort of highlights the four key targets that we've generated so far. One being the I'm not a vampire vein, which is, as I said, it's a large outcrop of low sulfidation looking epithermal quartz, but there's a clear overprint of breccias and stuff that sort of come through the earlier low sulfidation quartz, and then that looks high sulfidation, and thus inferring potential porphyry system at depth. Probably too deep, the porphyry in that particular spot. but geochemically, it models well with other sort of 3D footprint modeling sort of stuff that we do with Fathom Geophysics that sort of take the geochemical data and generate shells of where the porphyry may exist, basically. So I'm not a vampire. This classic low sulfidation target, but overprinted by a potential hydrothermal or porphyry system at depth with signs of high sulfidation epithermal stuff. Uh, Gold, silver, predominantly with a bit of bismuth and other bits and pieces. Perseverance is way up to the north, something we stumbled across about 2 days before we decided to put IP lines over it. Again, low sulfidation veins, but now in breccias that are overprinted with propylitic and advanced argillic alteration. So same sort of sequence, early low sulfidation mineralization overprinted by something that looks like a porphyry system. At Loki North, we've got really large low sulfidation systems. So these are 6 kilometre vein systems with multiple veins, lots of gatherings of gold, silver, copper, tellurium, lots of bismuth up to almost 4,000 ppm. Uh, Again, all these have lit up pretty well in the IP beyond the threshold for low sulfidation epithermal mineralization. And Redonculus, which is the big one down the south, the Redonculus, so they all sit in the same structure, which effectively is also mapped out by the mag valleys. So the structure through here, these things are all hanging around the sides. So Redonculus is a very, very large scale IP anomaly. It's undercover, but it does sit next to the extension of the I'm not a vampire vein. So again, inferring that there's some fertile system dynamics happening, at least next to the anomaly. Let's have a look in detail. There's Redonculus in terms of the size. You can fit quite a few large systems in there. It's the largest in the world. So it's a huge anomaly. It's one of those modeled porphyry things in the geochemistry. So you know, we've got chargeability from 25 to up to 65 millivolts, basically. It's a lot of pyrite. So, look, it could be anything. We're hoping it's a porphyry or something related to the actual mineralization. There's gossan sitting nearby here. And that bit of gossan that we got there, it runs good copper, moly, tellurium, selenium. It looks identical to some of the stuff that hangs around the edges of porphyry systems in the Macquarie Arc. So again, forgive us if we end up being wrong, but yeah, these are what these things sort of look like. Um, But, it could also be orogenic, it could be graphitic shale for all we know. We've got to drill it to find out. There are some shales around in the host. The host here is diamectite, but structurally, again, it's right on the main structure. And although there's a bit of coincident conductivity with the chargeability here, so low resistivity, potentially suggesting, shales or something like that. They're only semi-coincident. They're not fully coincident. They don't really make sense from an IP or geophysical point of view. But this thing here is purely high resistivity, high chargeability. That's unlikely to be any form of graphitic shell. And then a cross section of what these things look like. They sort of open at depth. These aren't small anomalies. These are quite, very big. And they sort of come up to within a couple hundred meters of the surface. So this is another view with some um, mags mag taking into account uh, resonance and remnants, suggesting, well, if these were mag lows, now they're mag highs, so these are either permocarboniferous or they have intruded somewhere between 485 and 463 million years. There was a small supercon of polar magnetic reversal, but either way, um, these are not Rysberg or typical porphyry sort of intensity numbers, but they are up to sort of 2 by 10 to the minus 3. So they're significant. They're likely an intrusive. And if you look at the relationship with the IP, it sort of looks like the IP is somewhat related to these things, but again, could be coincidence. I don't want to dwell on it too much, but yeah, there are likely some intrusives sitting under them. Again, just this is, I think, our whole we're applying for funding, uh, moving towards the big guts of the system through here. So if we step out a little bit further, we seem to be sitting in some form of big, big sort of ring structure. We don't know what it is. These are what the rocks look like. So that's the Gossan sitting right next to Redonculus. Um, Again, some decent tellurium, moly, copper, selenium sort of numbers. And from I'm Not a Vampire itself, this is an example of one of the breccias that have overprinted the low sulfidation vein, and the class themselves appear to be almost advanced argillic alteration and acid leached. So lots of things going on up here. So I'm Not a Vampire vein itself and Redonculus nearby. And this structure comes down through the side here. So back up to Perseverance. So it's what I mentioned earlier. We get actual mineralized low sulfidation veins now in breccia as clasts and overprinted by not phyllic, but polyphyletic alteration. So lots of epidote, fluorite, hematite sort of stuff. But again, very complex breccias. You can see again those chloroform crustiform bands that were mineralized once upon a time in some crazy breccia just sitting out there, even some tourmalines hanging around. So again, things that sort of look like they could be porphyry related that were once low sulfidation. But again, nice numbers in the IP, particularly for low sulfidation systems. So thresholds typically about 7 to 8 millivolts, so a little bit higher than that. So we're looking forward to giving this one a crack, this hole. Now, I covered it Loki North. Again, at the surface, this is just one large low sulfidation vein full of, again, blade textures and whole-form custom banding. Really nice IP associated with certain parts of that. So again, for scale, that's a couple of kilometers there. So about six all up down to there. And that intersects. So people interpret these things as fault, but that's separate fault. They're on separate faults. And then there's another one up here. Big anomaly up here, too close to an area that we go near in the short term. But certainly this will be one of the best targets to drill. Again, these very complex polyphase, multi-generational breccias. They look beautiful. And again, lots of bismuth up in the north. And again, gold to I think 1.2. Um, Silver's a few grams here or there, sort of thing. So the fertility's there, the size is there, everything's there, ready to go. Drill a holes to that. And I thought I'd just chuck a few more rocks up just to show what they're like. So again, proper gossans we get that were once well mineralized. So this is the thing from the edge of Redonculus. Here you've got some remnant sulfides with a bit of chalcopyrite still just scattered in, but mainly pyrite. It's very rare to get remnant sulfides at the surface on the particular project. The I'm Not a Vampire vein, again, these are probably sulfur salts and coliform, crustiform banded stuff, but also massive brecciated crap. Shingle breccia up the Perseverance. And again, the sort of breccias overprinted by sort of propylitic alteration. There are skarns nearby, and a few kilometres out, you've got what look to be CRDs, carbonate replacement deposits. Again, still placing you in the right area, but again, in terms of the hyperspectral survey, everywhere we get these things, we do see evidence of, you know, porphyroid, bickite, plus or minus alunite and stuff like that. So it all makes sense. Yeah, it's a huge area, lots of cool rocks. I guess these are some of the blade textures at Loki North that I was talking about. So these sit above the boiling zone of low sulfidation systems. So it's all pretty good. And I guess our next sort of major target is that Asgard Dome. We're going to show you these because they're pretty cool rocks. So you got UST textures, uh, magnetite to hematite. So some of this quartz may be magmatic at the top of an intrusion. I don't think it's the Dobie granite, the old one. It's something else going on there. Lots of specular hematite around, so things that were sulfide veins are now various shades of hematite and other stuff. So there's always blebs of chalcopyrite hanging around. I think there's might be a little bleb up here. But these we've interpreted as ingural bands, so these are big 3 to 5 inch bands of what were ex-sulfides basically. And these are on veins that, again, are up to 20, 30 meters high in some places and extend for up to 12 kilometers. So, yeah, big systems, and hopefully we get to drill some of them in a few months' time.